One video on intersections of lines in October is out. But I've got good news for all of you. Theodore is wide awake. He is ready for some homework problems. Perfectly on cue. He looks very ready. And he's out. All right, let's go. Let's do some homework problems. We're not going to start with that one. We're going to start with number 3. So if we go over to number 3 on the homework assignment, which is right, that's also number 15, right here. Let's look at the slope of this line. Remember, you can hit the magnifying glass. Shout out to the student who came by student hours today and reminded me of this. You can hit the magnifying glass to see the graph more clearly. This says find the slope of this line. So what we're going to do is we're just going to find some points on this line. You can notice there's a point here at -3, -1. So we have a point at -3, -1. This is kind of hard to estimate. Maybe this is a half, kind of hard to estimate. Okay, this point's definitely 0, 1. And what you can do is you can either use a slope formula or you can do rise over run. Let's look at those 2 points here and here. Our rise is we go up 2, and our run is we go right 3. Up 2, right 3, those are both positive. 2 over 3. That's what we think our slope should be. And if we use the formula, right, this is our first y1, this is our first y, this is our second y, this is our first x, second x. If we use the slope formula, we should get the same thing. Second y minus the first y, second x minus the first x. Minusing a negative is adding. 1 plus 1 is 2. 0 plus 3 is 3. Great. Both formulas give us the same answer of 2 over 3. Let's see if the computer likes it. Got it. Do number 12. Write an equation for the graph below in terms of x. So we know that this is a line. And as soon as we recognize that it's a line, we say, okay, y equals b plus mx. Now we just need to find the slope. And the vertical intercept, or the y-intercept, b. So we already just talked about how to find the slope. There's 2 ways. Here's a point, 0, -2. And here's another nice point, 2, 1. And you could say, well, we go up 1, 2, 3. We go right 2. Up 3, right 2. Rise over run, 3 over 2. Or you could use the slope formula. You could use this formula as well with our 2 points. All right. And now we have a point and a slope. We could solve for b that way. Plug this into our equation along with m, and you could solve for b. Or we could visually try to find our vertical intercept. What is our vertical intercept where it crosses the vertical axis? What does that intercept look like? Looks like -2. So we can just combine everything. Y is equal to b, which is -2, plus m, which is 3/2, times x. And there you go. How we do it. The last problem is what I really want to spend the most time on for this video. Let's say we have a car rental company and they're offering 2 plans for renting a car. Plan A is going to be $30 every day, 14 cents per mile. Plan B is $50 per day with free unlimited mileage. So for what range of miles will Plan B save you money for a 1-day rental? There's a lot going on here. Okay? A lot. So let's just start with what we want to find and work our way back. That's a good problem-solving strategy for application problems. Let's write down what we want. We want to know, to save money, the mileage must be greater than something miles per day. We want to know how many miles do we have to go for plan B to be better, right? When will plan B save me money? When is plan B better? How many miles do I have to go for plan B to be cheaper? That's a logical process. How many miles for plan B to be cheaper? Well, what does cheaper mean? Cheaper just means lower price. So when is the price of B less than the price of A? That's another way of asking this. Now it's just like that last example, example 10 from the notes. When is one function less than another function? We'll find out when their functions are equal to each other, and that's going to help us out. So we need to find when they're equal. So, because something can only switch from greater to less than where they cross, where they're equal. So find when they're equal. And again, this is going to be the cost. So, okay, let's set these cost functions equal to each other. We don't have the functions written down. Well, let's do it. What's the cost of plan A? Let's call that C1, cost function number 1, and it's a function of how many miles you're going. Right, that's cost. This is miles. What's that going to be? Well, it's $30 for every day, and it's already telling us that we're only doing it for one day. So for one day, it's just going to be $30. And we also have to pay 14 cents per mile. But what's wrong with what I've written down here? The wrong thing is C is going to be the cost in dollars. 30 is in dollars. But 14 is currently in cents. So we have to convert everything either to dollars or convert everything to cents. Probably easier to convert everything to dollars. 14 cents is $0.14. And now everything's good to go. That's the cost of plan A. So try to find the cost of plan B now. Pause the video. Try to find the cost of plan B. Should be easier. Cost of plan B, let's call that C2, is based on miles, and it's going to be $50 per day. Okay. And free unlimited mileage. So we don't have to pay per mile. So nothing goes here. It's just 50. All right. And you can, do some checks. If we do one day, okay, $30 and $50 for each plan, and like 10 miles. Well, this one charges you per miles, but this one's still just $50. Okay, so these cost functions should look about right. We're curious when this one is smaller than this one. So if we are consistent with our problem solving strategy from example 10 in the notes, we'll find out when they're equal. So we're finding out when they're equal. So they're equal when they intersect, when their outputs are equal. When is the second cost equal to the first cost? Well, the first cost is 30 plus 0.14 m. When is that equal to the second cost of 50? Just solve for m. Subtract 30 from both sides so that we can get the m by itself. We're going to get 0.14 m is equal to 20. Divide both sides by 0.14. Oh, I cannot do this in my head. we're going to get that at, they're equal when the mileage is 20 over 0.14. About 142.857. A lot of fair amount of miles. But actually, I don't remember what we're talking about. What are we talking about? A car rental company? Okay, if you're renting a car, it's not insane. Also, getting a flat car rental fee of $50 per day is a pretty good deal nowadays. Anyway, so they'll be equal at this mileage. So when is the unlimited better? Again, they're equal for 142.857 miles. Unlimited is going to be better when we drive at least that much. So unlimited will be better for 143 or more. Plan B is going to be better for 143 or more miles. And that's going to be our answer. So it must be greater than. I'm actually not exactly sure what kind of answer they want. Let's just put 142.857 and see if it likes that. I just noticed it said greater than. If it said greater than or equal to, I would say 143. Oh, here it is. Ooh. Make sure to read the instructions, Jason. 1 decimal place. So let's say 142.9 or 142.8 would both be appropriate here. There we go. They did find, they had that 857 as their answer, but they just wanted 1 decimal place. There's some hair splitting things that you could do here, but I'm not going to go into the hair splitting. And I'm glad that my open math doesn't go into the hair splitting. Let me know if you have questions about any kind of input issue. All right, there you go. Have a good one. Hope you enjoyed this section. And I will see you sometime, probably. Bye-bye.